Jane Richardson is the past president of the Biophysical Society. Thank you for joining us, Jane. You are chair of the Sunday Symposium, and that is celebrating 100 years of crystallography. Give us a brief interview of the symposium.
So the idea is that crystallography has been very, very important to biophysics, at least for the 54 years since myoglobin and hemoglobin, when we first had structures of big macromolecules. And the idea of the symposium is to show people that this is still active and exciting and important to biophysics now. And we're going to have, as our featured talks, 2 about hot new structures and 2 about hot new methods.
That's great, Jane. Now, crystallography is obviously of major importance to biophysics. The United Nations just declared 2014 the year of crystallography, and you just co-authored an article with your husband that appeared in a biophysical journal listing the most notable 54 macromolecular structures. Talk to us more about this.
Well, that was really fun to do. Very interesting. It's a very personal selection of ours, and since it's in Biophysical Journal, we've emphasized structures that are important to biophysics, not so much important in general necessarily. So it's not the ones that people would expect always. They're things that are important either because they opened up a whole new area, like the first membrane structure or the first RNA structure, or ones that have been used to actually enable other biophysical techniques and then model systems for research.
Fantastic. You were also talking to us about licensing.
Yes. Well, this is the article, the cover for the article that shows some of the illustrations of these structures. And having good illustrations that can be used on places like Wikipedia is just increasingly important for our science. That if you want to use an article to understand a technique or to understand a result, you want good illustrations of the experiments and of the results. And in order to do that, you have to have open license media. And so we're having a session on Sunday, the Wiki Project Biophysics, and explaining to people particularly why they should be uploading good open license media.
Now, crystallography is obviously huge in basic research. Why is it so important to basic research?
Well, having a crystal structure of your favorite system does not solve all your problems, but it's very hard to really understand such a system without the structure. It makes an enormous difference. And for instance, in order to understand mechanism, really how at the atomic level of detail do things work, how do proteins interact with each other and with small molecules, and how do they do their function. For mechanism, you really need that detail of exactly what the thing looks like.
So Jane, how important is crystallography going to be for medical and health research in the future?
Well, at the moment, a lot of what's exciting, both in the basic biology research, but also for biomedicine, is big, complicated assemblies and systems. And so these are the things we call molecular machines. They're big complexes that interact with multiple proteins or protein and nucleic acid. They're very dynamic. The pieces of them go in and out. They, turn around and do stuff. We're much more into the importance of motions and also the importance of interaction networks, which do a lot of the control and signaling functions that are so important. And we're getting much better now in crystallography at doing these very big structures. They're still hard, but they're possible now. And so those structures, and particularly the way now we combine methods, so it's not just crystallography, you use a combination of crystallography with electron microscopy or NMR or SACS or other computational methods, and that gets you much more leverage. So understanding those systems is really critical to controlling biology well enough to do really better medicine.
Thank you so much for joining us, Jane Richardson.